Today we're going to learn about speed and velocity. Here's our objectives. Javier and Lucas are friends. They both like to go out in the morning and cruise the coastal highway. Lucas rides his motorcycle at a constant speed of 20 miles per hour, which means his speed doesn't change. Javier rides his skateboard at an average speed of 12 meters per second. His speed changes because he slows down and then kicks again to speed back up. To measure average speed, we need to take the total distance traveled and divide it by the total amount of time. Average speed doesn't tell us if the object has been speeding up or slowing down, unlike instantaneous speed, which is the speed an object is traveling at a specific moment in time. This can be measured using a radar gun or a speedometer. Sarah goes 2 houses over to babysit a neighbor's child every day. From door to door, it takes her 75 seconds to travel 90 meters, giving her an average speed of 1.2 meters per second. But lately things haven't worked out so well. Sarah has been running late. And this time, she forgot something very important at home. So she walked 90 meters in 75 seconds to the neighbor's house. And then she ran back to her house to grab her phone. And then she ran back another 90 meters. Whew! So how far did Sarah actually travel on this day? Back and forth and back again, she traveled 270 meters and it took her 150 seconds. Which means her average speed was 1.8 meters per second. But how accurate is this measurement? When she explained it to the neighbors, they said she wasn't going 1.8 meters per second because her displacement was only 90 meters, not 270 meters. Displacement is the distance from the starting point to the end point. They said she was only going 0.6 meters per second. So who's right? Well, in case you haven't guessed it, her neighbors are both physics teachers. What's the difference between Sarah running really fast at 1.8 meters per second or her trudging along at 0.6 meters per second? The answer is, which direction was she going? Imagine if everywhere Sarah went, she ran 90 meters forward, 90 meters back, and then 90 meters forward over and over. How long would it take her to run 270 meters? It'd be like a long time. Because objects can change direction, when we measure how fast something is going, we use velocity. It measures the change in position over time. It includes both speed and direction. Let's take a look at the equation. Velocity equals the final position minus the initial position, divided by time. So we don't measure distance, we measure the displacement over time. So for this trip, Sarah's average speed is 1.8 meters per second, but her velocity of 0.6 meters per second is a better description.